Hello again. How are you doing? OK, I'm going to try that again. How are you doing? Yeah, come on. OK, I was expecting better, but yeah, you never know. So my name is Etienne. I'm a senior dev engineer at Microsoft. You can follow me on Twitter. I have no friends, so please do this. And I'm going to talk to you today in the next 25 minutes or so about containers. Who already heard about containers before? No one heard about containers before? Few. OK, yeah. So I'm going to first do an intro to containers for you to have an idea of what it is. And then we're going to talk about what containers mean in the Windows world. So basically, a container is a VM, a virtual machine, without an OS. So this is the main difference from a VM. It's somewhere, it's a place which is isolated from everything else, where you can run some code. So inside of the container, you have the bin, the libs, everything that you need. You also have the code for your app that runs inside of it. So it's something isolated that you can run on your computer or on the server. The other differences that you have between VMs and containers are that a VM basically virtualizes hardware. So this is like each virtual machine is an OS, and it's running. It seems like it's running on its own hardware, but it's just shared across all the VMs. So you have the hardware, the host OS, the hypervisor, and then the VMs with their OS inside of it. It's usually slow to start up, but you have everything you need inside of it. A container virtualizes the OS. So there is, as you can see here, there is the main difference is that you have a layer that is missing. You have the hardware, you still have the host OS, but on top of this, you have a container management tool, which is can be Docker or thing like that. And inside of this, we are running containers. Containers are sharing the kernel of the system, so they don't have to run their own OS inside of it. It's smaller, and it's also starting faster. So why do we use containers? The main reason is because it costs less. Or the first, maybe not the main, but the first reason is because it costs less, because you can have more containers on the same machine that you will have of VMs. Because it's smaller, so you can have more of them. It's a higher density. So it's easier to deploy on a dev machine to test. It's also easier to deploy on a production environment and test environment. And everything, all of these make your business more agile. And you like that, right? So to create a container, if you never seen this, this is important. A container is created from a manifest, which is a file that describes that you want to have in the container. Everything you will need inside of a container to run your app. So it's basically, it's a simple language like this. You can see that we can say we start from an existing image, which is here an image that can run ASP.NET in this example. And then we have some arguments and some optional variables. You can say, I want to work on a specific directory, and then I want to copy the files that I have on the current folder, where you might have your source code, for instance. And I want to copy this inside of the container, and then expose the port 80. So this is basically how you simply have a container running an ASP.NET website. Then the container is the running version of the image. You can have your developers, mostly of your developers. So an equivalent might be that the image is a class, and the container is the object that we created from the class. So a container has multiple layers. When you create one, you can say, I want to start from the base image. In this case, it's Debian, for instance. And then you add more images on top of this. You can add multiple layers to build exactly what you need. And then you have the container layer. The container layer is where you put your code and all the binaries that you need to run the app. Everything is read-only except for the container layer. So most of the time, when you have a real-world application, you will have and you will need more than one containers. And you might need them to be able to talk to each other, have the same network, and have the database there, and then the website here, and they have to be able to contact each other. To do this in an easy way, you will use composition. Composition is another file which has the extension YAML. You can see here. And you use compose, like Docker compose, to say, OK, I have these services, so 2, 3 services, and this is the image that I want to launch, and this is the Docker file that I want to launch too. I'm going to switch to a quick demo here. OK, so I'm on a VM somewhere. It's not important. I am on PowerShell here. So basically, when you want to do containers, you will use Docker. So I'm on Windows, and I'm going to use the Docker command line. And I can do Docker images. So when I do this, it's going to show me all the images that are available already on this computer. In this case, I have the Windows Server Core and Nano Server. You can see the difference for these two images. It's like this one is 1 GB, this other one is 10 GB. So it can take a long time to download. Basically, you download them from a public or a private registry where you have all the images that you need. You download them locally, and then you can use them to create containers. So this is not a running container, and I'm going to launch one now. So I can do Docker run. I'm going to ask it to run in an interactive way, and I'm going to use here the ID. So I'm going to run the second one, which is 6C3. You don't have to put all the ID, you can recognize this. And then I want to run in an interactive way PowerShell init. So it's going to take a few seconds, and which is really faster than a VM. So more than a few seconds, maybe a little more than a few seconds. And basically, you can then have, so you should never say a few seconds, because then it takes always more. So now it's starting the container, and I'm inside of it in an interactive way on PowerShell, and in a few seconds, yes, I will be able to type. So if I do dir, you can see that I have some folders because I'm in the C, but inside the container, it's isolated. So everything is separated from the host OS, and it's going to appear in a few seconds, maybe a minute. You never know. OK, there you go. So it's running somewhere, this machine, so it takes some time. So you can see here I have Windows users and everything. If I now do, if I count the processes that are running on this machine or this container, you can see I have 18 of them. If I exit the container and close it, then I will do exactly the same to prove you that it was isolated. So if I do this here, OK, PS, let's count. There's some music. And here you can see that I have 82. So it's clearly different and isolated. Let's go back to the slides. So now that you are all experts about containers right now, after these 5 minutes, let's talk about how you can use this in the Microsoft Word. So in Microsoft, you can, or in Windows, you can use two types of containers. The first one is what I used right now, which is Windows Server containers. So you have this, you have the hardware, Windows Server, Docker on top of it, and then you have containers. They use all the same kernel, but they are isolated from one another. This is not a security isolation, meaning that you don't want to run untrusted code on this, because you can have some security issues. And this is when you want to use Hyper-V containers. The difference between Windows Server containers and Hyper-V containers is that in Hyper-V containers, it's running, like every container is running on its own small, really light VM. It's not creating a whole VM with the OS and everything. It's a lightweight version of the VM where you have the container. So each container has its own kernel, and you have security separation that you get from the VMs. This is the two way you can use. So this is on a machine. When you want to run this somewhere in the cloud on Azure, you have a lot of different services that we provide for you. The first one is App Service. Maybe you already used web apps, for instance. In App Service, you also have web apps on Linux that we released recently. We have available there. And this is running basically on a container. So you can use this service, and instead of choosing web apps on Linux, you can select a container, you can select an image more than a container from the public registry or from a private one that you have and own. And this app service is going to be created from there. So you can run whatever you want there, an API or a web app inside of the container directly. And you get everything that you expect from PaaS services, which is scalability, automatically restarting your VMs, and all that kind of stuff. Not the VMs, but the containers. You can use Service Fabric, which is something that we use at Microsoft to build a lot of products. It was originally created for having microservices, and you have health monitoring and a lot of features there. And you can now also use containers inside of Service Fabric. We also have Azure Container Service, ACS, which basically is Microsoft hosting for you a version of an Azure container cluster management tool, like Kubernetes or DCOS or another one. So let's now just recap the container ecosystem. You can have containers on the Windows or in Linux. To manage these containers, I show you Docker, I was on PowerShell. You can also use Rocket. So this is basically command line tools that are helping you managing these different containers. Then, when you create an image from a Docker file that I showed you at the beginning, you can publish it on Docker Hub or on Azure Container Registry. And then you can use it. You can use it on a Windows server, on app services, I just talked about this, or Service Fabric. And usually, you manage these using orchestrators. So Docker Swarm, Kubernetes, or DCOS, this is basically a way to manage a lot of containers when you have a huge app with a lot of them. And to have monitoring and to be able to get this Docker Swarm or Kubernetes or DCOS up and running on Azure, you will use ACS. So you might have now a question about, OK, this is on Azure, I know how to create a container, but how do I integrate this inside of my developer workflow and my team workflow from the code I write to production? So everything begins inside of the developer computer. Not everything, but the code begins there. And you will run here, have code, debug, test, and do everything. And you will pull images from the Azure Container Registry and then test your app inside of these images. When you're done with some code, you will push this in a source control. You can do this in VSTS, obviously. You will have automated continuous integration running, building your app, testing building the image for the container, and then publishing this in the Azure Container Registry. And manually or automatically, you can deploy this on environments and run it on all the services I talked to you about. And the last step is to monitor this into production and then have actions when something is going wrong or you want to improve something. You can just use the monitoring and all the tools we have in Azure for this. So we announced at Build container tools inside of Visual Studio. It's a great way for you to start if you never used this for multiple reasons. Basically, it's a set of tools. I'm going to show you how it works to run, to debug, and test your applications. And locally, on the local machine, you can have everything that you would expect from Visual Studio. Breakpoints, debugging, you can have it in refresh and continue. And you can also, and this is why it's great to start, you can use scaffolding to pre-create Docker file for a specific project. Let's see how it works. So here, I Visual Studio with an existing project that is not on Docker and it's not on a container yet. And I want to change this to go on a container. So I have two services. There is the web one here, which is basically the front website, and I have a service that is used by the website. I can do what you would expect and what you like to do in Visual Studio, right-click on everything. So I can right-click here. I can click on Add, and I can just go and ask for the Docker support. So this is the scaffolding part. It will have a look at my app and see what it is, and pre-creates an image manifest file. So I can use this as a base to then create a whole container that is running. So I already have a version of this website containerized and running here. And I can, so it's a website. We don't care really about what it is. I can, when I click here, it is normally hitting a breakpoint here. And for some reason, it is not. So I'm going to do something that you don't want to do at home. I'm going to restart debugging. OK. So I'm having an error with the network now. And I'm going to do this. Can you all cross all your fingers on your hands and your feet? Yay? It's going to take like a few seconds. So you can see what's happening here. It's creating the Docker image and everything. And we have some issues now, because you can see here, this is a preview version of Visual Studio containing these container tools. And I always do the demos with the preview version, because it's more fun. It can break and everything. So if this works, I want applause. I don't care. OK? So let's try it again. Clicking, it worked. It's the first time I get applause because I hit a breakpoint in my code. So you can see I have everything that you can expect from debugging. I have access to the variables. I can hit breakpoints. And this is my first Docker image. If I hit F5, it's going in my second one, which is on the right, or it should. Yeah, so let's pretend it was there. And you can debug both containers running on the same machine and have breakpoints from one single instance of Visual Studio. It just run like this. So I'm going to stop this. And when it's not preview anymore, it will work like a charm. And now, what I want to do is say, OK, that works on my machine. I want it to work now and to be able to deploy and add some DevOps on top of this. So we also have something in right-click for you. I can right-click here and set up continuous delivery. This will open something that I can use to configure everything I need, and everything is already done. So I can just go here, and I have, what it does is it automatically set up for me a build that I can use here, which all the steps that I need. It's building the solution, running the tests, and if it works, it's creating an image in Docker, and then it's going to push this image to the Azure container registry, so everyone in the company can use it. And then when I have something that works and I'm ready to run it into production, I can go here, which is the release part of Visual Studio Team Services. And it's going to basically take the results of the build and publish this inside of Service Fabric here. You have a tasks from inside release to do this kind of deployment. So you can see here that it's running. I can follow, this is the power of Service Fabric. I can follow the health of my environments and see if something is not working. I can see it here really easily in this dashboard. I also have the same thing that I showed you during the keynote, which is a personalized dashboard. And you have services running inside of the container to show you information about the container, like the disk status or the CPU from directly inside the container. I can also zoom here and have exactly the same thing and experience. If you have an error inside of a container, you can see it here pretty easily. So it's important to understand that we call this lift and shift because it's the advantages of containers. Containers were created, like the real ones, the big metal ones, in a standard way, so you can put it on any chip, and you can take it off and put it on any dock. And this is why this is called Docker, and this is why it's containers. And this is basically what we did. We took an IaaS, an ASP.NET app, and we put it on a container that I cannot deploy wherever I want. That was everything I wanted to talk to you about containers today. You can go and have a look at microsoft.com/containers to know more and learn more. You can also have a look at every containers we have that Microsoft publish in the long URL, which is here. And if you have any other question, I will be here today and tomorrow. So I wish you a really great day, and see you in a bit.